Okay, here we go. Problem number 3, last one. This one is, again, similar. It has a missing side. Doesn't matter which one they're asking you here to find. You're going to go ahead and just find all 6. Find all 6 trig ratios. Sometimes they say trig functions. And again, we have a missing side. I need to find this side first. All right. Okay, so let me do the work over here. I got what? This is the way it's correct, like this. Here's the right angle, so that's 6, 4 root 2. I'm gonna find that missing side up here. So this is the C side, right? For Pythagorean theorem, is a squared plus b squared equals c squared. So that makes this the C side. And again, this one can be A and this one can be B. It doesn't matter. But this one has to be C. All right, here we go. So that's going to be 6 squared plus... Oh, no, that's not right. What the? C is over here. Oh, don't do that. A is over here. That's A squared plus B squared is 4 root 2 squared equals what? C is over here. 6 squared. I almost fell into the same mistakes a lot of students do. All right, watch out when you put this. Make sure it's correct. Well, I know 6 squared is 36. I got that. A squared is just A squared. But here, this is 4 root 2 times another 4 root 2. That's going to be, again, 4 times 4, which I'm going to write here. 4 times 4 times. And then the square root of 2 times the square root of 2 is 2. All right, don't skip that part. Don't skip that part there. That's where people mess up. If you get this wrong, then this side will be wrong, then all the trig ratios will be wrong. So do this carefully. A squared plus 4 times 4 is 16. 16 times 2 is 32. 32 equals what? Equals 36, right? And subtract 32 and subtract 32. A squared equals 36. 36 take away 32 is 4, right? Oh, 4 is a perfect square number. I take the square root of both sides. Gonna get A is equal to what? What's the square root of 4? 2. 2, 2, 2. All right. I like this. I'm getting some good numbers there. So what's this missing side that this is a 2. And we go back to our original problem over here. All right, here it is. We got it. It's a 2. It's not missing anymore. I got it. All right. Now we got to do SOHCAHTOA. Let's find those first 3. So sine is over H, ka. Cosine is A over H, TOA. Tangent is O over A. All right, you should be good with this now. So I gotta label the sides first. Here I go, getting ahead of myself. I gotta label the sides now for, not with the ABCs, but with the hypotenuse. Hypotenuse is the diagonal side. Opposite is opposite of where the angle is. That's the O side. And the last one's adjacent. Yeah, make sure we do that. All right, here we go. We got to see it. Don't just try to keep it in your head or something. All right. Sine is what? O over H. So that's 4 root 2 over 6. Cosine is going to be A, 2 over H, 6. And tangent over here is going to be what? O, 4 root 2 over A, 2. All right, I think you can notice something, right? What do you guys notice? All of the whole numbers we can reduce. These can be reduced. These can be reduced. These can be reduced. We want to do that now. So I'm going to go ahead and do it, right? Divide by 2. Are these reduced by 2? So really sine is going to be what? 2 root 2 over 3. Cosine is going to be 1 over 3, right? Divide by 2, you get 1 over 3. And divide by, 4 divided by 2 is just 2. But you know what? I want to leave it like this. It is going to be 2 root 2, but I really do want to leave it over 1, right? Right, because 2 goes into 2 once and 2 goes into 4 twice. I actually do want to leave it like that, right? Because I got to flip it over right now to find the other 3. So yeah, look at it like that. But really in the answer for tangent, will just be 2 root 2, okay? So we got that one. All right, now let's go and find the other 3. Oh, ignore that. So cotangent would be the reciprocal of that, 1 over 2 root 2. Cosine, oh no, actually this one. Sine is what? Cosecant is the reciprocal function for sine. So reciprocal of that is 3 on top and the 2 root 2 on the bottom. And then this one is secant. The reciprocal of cosine is secant, and the reciprocal of 1 over 3 is 3 over 1. So really secant is just going to be 3, right? 3 over 1 is just 3. All right, now I'm going to look and see which ones are done. I already said tangent is done, so I already boxed it. Cosine is 1 over 3. That one's fine, and it's reduced. Boxed it, that's done. This one's good, right? Because the radical was in the top and everything's reduced. So this one's already done, and this one's good. So I got 1, 2, 3 done. Which one else is done? Which one's good? This one. Secant is 3 over 1, which is just 3. Oh, okay, that one's good. So it looks like we're always going to fix maybe like 2 of them or something. These are the ones we got to fix, right? Can't have a square root in the denominator. So I got to fix cosecant and cotangent. Let me copy cosecant down over here. I'm going to copy cosecant as what? 3 over 2 root 2. Cosecant is 3 over 2 root 2. All right, let me fix it here. Remember, I'm okay with the whole numbers. It's just this radical that is not good there. So I'm just going to have to multiply by a root 2. You don't need to multiply by the 2, just the root 2. Just the root 2. So that's going to give you what? 3 root 2 over. And then what's happening here? I got 2. Oh, the root 2 times the other root 2 is... Okay, so I got this 2 times, and then these will make another 2. So 2 times 2 is going to be 4. There's your answer for cosecant. Cosecant is this. All right. Last one is cotangent. We've got to fix this one too, right? We could just do it here. Multiply by root 2. Multiply by root 2. 1 times root 2 will give you what? For the numerator, 1 times root 2, well, it's just root 2. And the same thing here. This is a 2, this 2, and then times what's going to happen with the square root of 2 times another square root of 2 is going to give you another 2. So here will be the answer for cotangent. All right. That is it. Thank you so much.